See question number 1. Which of the following instrument that is suitable to measure thickness of a wire? We are using normally two reasons to measure the diameter of a wire. The instrument is micrometer screw gauge. If you can remember, what are those two reasons? First one, least count is small, 0.01 millimeter. And second thing is, it consists with ratchet mechanism. Ratchet mechanism prevent overpressing the wire. Then correct answer is second one. Question number 1, correct answer is second one. Wave velocity of a certain, question number 2, wave velocity of a certain is given by V equal K GH to the power of X and Y. Question number 2. V equal K GH to the power of X and Y. Dimensions LT minus 1. If it is not specially mentioned, we have to consider K dimensionless. Can you note it? Dimensionless. G LT minus 2 to the power of X, L to the power of Y, H is height, height is L. Then X and Y respectively, it's not C, X and Y respectively. Then it becomes T to the power T minus 1 equals minus 2x, X becomes half. And we can consider L base. Here we have 1 equal X plus Y. Then X is half, then Y becomes, this is minus half, then 1 minus half is half. Then X equal, Y equal half, right? Then correct answer is second one. Okay, right, done. Can we check question number 3? Third question. You are given the relationship of a vector A equals B plus C. If you are given such an arrangement, you should know these two are the magnitudes. This one is the resultant. For an example, if this is force, this is also force, resultant one is also force, but as the configuration of the vector addition, resultant of these two equal to this one, right? First identification should be this one. That when A is mentioned, just 5, any unit, no matter, but should be the same unit of each one. And B is 4. This is 4. And this could be 3, right? This is Pythagoras theorem, yes? 5 equals 4 plus 3. Then 4 squared plus 3 squared could be same as 5, right? Okay, then we have to consider like this. By considering such an arrangement. If we consider this one is 3, which is C from here to here, then B represented continuous line of these two bases. It represents 4. Let it be. Then should be equal to C. Then vector addition, this could be the resultant. This one is the resultant. That is A. In magnitude, that could be 5. any unit you can use, but all three factors, this and this should be included with the same unit. පැහැදිලි නේද? මේ හැමෝටම එකම unit තියෙන්න ඕනේ. Otherwise, this vector addition won't be applied. පැහැදිලි? Right. Then this should be the known angle of 90 as Pythagoras configuration perfectly mentioned. Clear with that? Okay. Then they need the angle in between A and C. A is this one. C is this one. We need, so we can say cos theta equate 3 divided by 5. Then theta becomes cos inverse 3 of 5. That's correct. Another one we can say sin theta 4 divided by 5. Theta becomes sin inverse 4, 5. And we can say tan C, tan theta. Tan theta is 4 by 3. Then theta becomes tan inverse 4 by 3. Out of these three, you can have the correct answer. Right? Can you copy this one, Putta? According to the arrangement, we have only this one, no? Right. Then correct answer is cos inverse 3 by 5. Answer is this one. Can you put the correct answer? උත්තර ආපු නැති අය හරි උත්තර ගනිද්දී මොකක් හරි වෙන විදියකට කල්පනා කරලා ගත්තු අය ඉන්නවා නම් හරියට process එක note down කරගන්න. Okay, question number 4. Fourth question. Right. You are given in the vector diagram, it shows R is perpendicular to P. Here you are given P. Vector indication P into this side and R indicated into this side. It's like this. And the third one should be Q, no? You are given. This one is Q, right? According to the basic arrangement, 2R equals Q, no? Twice of R equals Q. That is important. This is, if this one is R, this could be 2R. Okay. They need the angle in between P and Q. Angle in between P and Q. According to this one, according to this one, there is no triangular base of the forces or any kind of vector. Let consider this one represents force, this is force, and this is force. All are all configuration related to force. Right? If you assume this one is force, this is force, and that one is also force. But the resultant indication is not perfectly indicated in the diagram. Is that clear? Why? According to this one, management of this one and this one won't be equal to this one. Reason, basically we are considering forces like P and Q. No? Resultant is considered as R, right? එනම් P වලයි Q වලයි resultant එක මෙහෙම එන්න නම් මේ forces දෙක අනිවාර්යයෙන්ම set වෙන්න ඕනි මෙහෙම කියලා වාට අහු වෙනවද බලන්න. According to the configuration of P and Q. පුතේ මේ දෙන්නගේ resultant එක මෙහෙම නම් forces දෙක තියෙන්නේ මේකේ මැද්දේ යන්න විදිහක් නැහැ මෙතන. පැහැදිලි? Why? It is drawn like this. No? තව ටිකක් පැහැදිලි කරොත් මෙහෙම. The resultant is perpendicular to, let's see, the resultant is perpendicular to this one. No? It's like this. Then, if this is P, the resultant should be this one. This is R. Then Q should be lined like this. If so, the statement is correct. R is the resultant. Resultant should be perpendicular to P. If so, third force of the second force of Q should be lined greater 90 angle. Optimum angle එකක් වෙන්න ඕන. බලන්න කතාව තේරෙනවද කියලා. Right. Can we copy this one first? You are asked to find this one. Okay, like this. If we can note reverse value of P, P is reversed like this. If so, R could be this one. R, this is Q, and this one is, sorry, this one is P minus P bar. It's minus value. It is reversed. Then this one is Q, this one is P, then this one is R. Then you are asked to find this angle. Let it X. Okay, that should be the question. Okay, then we can first thing find this one. How? Sin theta equals R over Q. In magnitude, sin theta becomes R is R. Q is twice of R, 2R. Done. So, sin theta becomes half, then theta is 30. But this is not the correct answer. Perfect answer is what do you call this one? So, 180 equals x plus theta, then x becomes 180 minus 30. Answer is 150 degree. Done. Can you copy this one? The perfect answer is fourth one. Fourth one is the correct answer. Okay. Can we check question number 5? Fifth question. An object starting from rest moves with a constant velocity. But can you change that position? It should be constant acceleration. It has typing mistake. Can you recorrect that one? Can you correct? With constant velocity, can you note down that one? Constant acceleration. Yes, not constant velocity. It should be constant acceleration. Okay. Constant acceleration take place. If it is constant velocity, no matter what, the answer is first one. No need to simplify. If it is constant velocity, answer should be first one. Anyhow, change the question, constant acceleration. And from here to here, it covers 10 meters after first second. And you are asked to find in here, second completed. You are asked to find this one. Okay, let it take. Can you take 1 minute to complete that one? Okay, we have typing mistake here. Can you recover now? බාණ්ඩ තප්පර 30ක් විනාඩියක් වගේ ඇතුළත හදලා ඉවර කරා. Okay, enough time. Let's see. Basically, we can apply S equal ut plus half at square, u0 at the beginning, then S equals half at square. We can say distance in between each consecutive second, delta S, directly proportional to delta t square. This is special thing to apply any kind of question starting from rest and mostly the constant acceleration or deceleration during a given time session, time duration. So delta S is 10 meter within 1 second, 1 squared minus 0 squared. At the beginning, time is 0. And next, distance x directly proportional to final seconds, 2 seconds, 2 squared minus 1 squared. Dividing each, proportionality becomes equal. Identical substitutions, same equation is used or same relationship is used for the substitution, then proportionality can be converted to equation. And here 10 over x equal 1 by here 3. Then x could be 30. In the second, it has covered 30 meters. Then correct answer is third one, but no matter. If you got first answer at the beginning, at the initial case, then you can take the correct answer, no matter, okay? But target is constant acceleration, right? Okay. Now, can we check question number 6? Number 6. A bullet loses 1/20th of velocity like this. Here we have fixed target. When a bullet fires with the velocity of v, it loses velocity 1 by 20, 1/20th, v by 20 is the drop of velocity. Then availability is 19 divided by 20v, no? It loses v by 20. Is that clear? Yes, common denominator 20. 20v minus 1v. It's 19v divided by 20. Clear with that? Right, done. Then output velocity is this one, right? Now you are asked to identify the least number of planks required to stop the bullet is. If it is like this kind of n number of bullets are needed to take the final velocity of the bullet 0 at a certain position. Okay, if you need, we can draw a certain diagram like this, no? Okay, then you should select the suitable equation to apply. What is that? V squared equation. Okay, can we write v squared equal u squared plus 2as? Then taking this one into this side, then we have difference of squared velocity at initial and final equal to 2as. A is deceleration. Anyhow, we have to assume total deceleration remain constant value throughout the entire motion. ඒක assume කරන්න නැතුව අපිට මේක හදන්න බෑ. ඒක ඔයාලට තේරුම් ගන්න පුළුවන්. Right? Okay, then we can say here delta v square directly proportional to s. This is the basic function to apply the equation or apply the database. Can we identify that one? Yes. Then from here to here, squared of velocity difference becomes v squared minus 19 over 20 that of V square. Done? Yes, then directly proportional to S. S is, let this length of a Planck is X. So, is X. Right? We got here A remains same throughout the entire, that is an assumption, right? Okay. Then, finally, if the bullet enters like this, finally, it should have zero velocity. Then V squared minus 0 proportional to X into n number of plates available, right? Okay, then we can divide each. So here we have V squared common factor 1 minus 19 squared over 20 square, which is 400, right? Okay, equate X over Xn divided by V squared. Identical factors cancel. Okay, then we have here 1 minus here 400 common denominator. It's 400 minus 19 squared, 384, right? Okay. Equal 1 over n. Then take n equal 400 divided by 400 minus 19 squared. Okay, then can we simplify now? Nineteen squared is 361. Okay, then this becomes divided by 39, right? It should be 10.25 like that. And minimum number of plates won't be 10, no? It should be 11. Fourth answer is the correct one. Okay. Question number 6, correct answer is. Okay, can we check question number 7? Number 7. Consider following statement A. Velocity is equal to rate of change of speed on a straight line. Care should be taken about all the terms in the whole statement, right? Velocity is equal to rate of change of speed. A, completely wrong. Why? Velocity is equal to rate of change of displacement. A is wrong. Right? A, wrong. B, an object can have constant speed. An object can have constant speed, but variable velocity. Can have. Like may have, no? තියෙන්න පුළුවන්. Let's see. An object can have constant speed like this. Here we have circular motion, right? An object represents the motion on a circular path like this. Then put at here, magnitude of speed directed like velocity. Velocity is directed along the tangent. At here, velocity is directed along the tangent like this. And at here, velocity is directed along the tangential line drawn to the circular path. Velocity is a vector quantity, then it has definite direction clear. Done. It may have constant speed. The object revolves around a circular path with the constant speed. By applying constant effort. then it makes a constant speed throughout the entire motion. Constant speed maintained, but point by point, variable velocity occurred. In a circular motion, that can have, then B correct. But straight line motion, it is completely wrong. Why? On a straight line motion, speed and velocity both are same. On a straight line here, velocity and speed v. On a straight line, velocity and speed same. On a straight line, velocity and speed same. May have same value. Can have. An object can have constant speed but variable velocity. Then B is correct for this kind of motion. B is wrong for this kind of motion. As it is mentioned, can have, then it can have. Then statement B correct. Statement B is correct. Right. Can we see statement C? Speed is a scalar quantity. Yes. Whereas velocity is a vector quantity. Correct. No doubt about it. True. C statement is, but today the doubt is you are asked to identify incorrect one. ඔන්න ඔය නෙගටිව් ෆෝම් එකෙන් විභාගෙට අහන ප්‍රශ්න අපි මාර කොන්ෆිඩන්ස් පිට හරියටම හරි උත්තර තෝරලා හරි උත්තරේ මාක් කරන මට්ටමට අපි හැදෙනවා. පැහැදිලි? ඒක එක්සෑම් එකේදී ලොකු ඩවුට් එකක් වෙන්න පුළුවන් අපිට. අහන්නේ ඉන්කරෙක්ට් එක. බලන්න එක කීයෙන් කී දෙනෙකුට අහුණාද කියලා. You are asked to identify incorrect one. Then it should be A. Only A is the incorrect one. The other two are correct ones. Then correct answer is first one. Right? Can you mark it? Okay. Method note එකක් වදිනවා. In a circular path, constant speed, it may have constant speed. In a circular path, it may have constant speed. Constant speed. Constant speed. But velocity changes as the direction is changed. Velocity changes as the direction is changed. Okay, right. Question number 8. In the given figure below, the position time graph is mentioned. So the position time graph, let's see number 8. Position time graph like this. Position means displacement against time. They need impulse at the second, 2 seconds. At here, it's 2 seconds. At this case, this position is 4 meters, right? Then by considering this gradient, tan theta, you will have opposite base 4 meters divided by time 2, it becomes 2. Displacement divided by time is velocity, right? This line throughout the entire motion from here to here represents constant velocity. Constant velocity available. The value becomes 2 ms minus 1 until from here to here velocity remain constant. And after reaches to here, suddenly at here, it comes to rest. Why? This whole line from here to here maintain rest. Then this velocity could be 0. Then what is impulse? You should remember that one. Impulse is change of momentum. Then impulse is this one. mv minus mu. So mv, mass is 0.1. Final velocity. We identified final velocity 0 comes to rest from initial velocity 2. So it's 0.1 into 2, 0.2 kg ms minus 1 or Newton second, but it has minus sign towards the moving direction. As the velocity comes to 0, impulse is backward impulse. Yes, impulse is backward one. Velocity adu කරන එකක් නේ පුතා. Velocity වැඩි කරොත් අපි කියන්නේ forward impulse, moving direction, directed. But this impulse is going to rest the object. The object comes to rest due to the case of impulse, no? Right, now it could be minus. Then minus sign is mentioned in the answers, right? So correct answer is second one. Second answer is the correct one. Okay. Question number 9. Number 9. The maximum range of projectile is 16 kilometers. But you should remember, maximum horizontal range is made by 45 degrees with the velocity u. This is 16,000 meters. Then horizontal range is written u squared over g sine 2 theta. මේකෙදි මතක තිබ්බොත් ලේසි ගණන් හදන්න. Right, s 16,000 u squared to be found g 10 sine 45 into 2 90, it becomes 1. So we have u squared is 16 into 10 to the power 1 2 3, this one 4, its root is the answer. Then u becomes 400 ms minus 1. This is simple question. Only we have to substitute the values and take in the answers. Answer is third one, right? Question number 10. The man standing on the top of the tower like this. Top of the tower. Two spears A and B. He drops the spear A downward, drops. Downward velocity 0. And throws the spear B horizontal. Throws spear B with a certain velocity u1, or let it u, right? No matter. Right. Horizontally, which means downward velocity 0. Then this one arrival to the ground from the vertical velocity 0. This one is also arrival to the ground with the vertical velocity, downward velocity 0. Then both arrival to the ground at the same instance. එක්කෙනෙක් අතාරිද්දී අනිත් එක්කෙනා හරහට විසික් කරන්න. It is horizontal projected one. Then vertical downward velocity, both the cases remain 0. Then if you apply this equation for both the masses, this and this towards down, both should be covered same distance, which is equal to the height of the mountain or building, any kind of given thing. Initial velocity, both 0. Both are having same gravitational acceleration. Then this is numerical value constant. As h is same, t could be same. Mark karagana. Then both arrival to the ground at the same instance. That's the first point. Okay, done. Right. Next one. Then A statement is correct. Both spears will reach the ground simultaneously, yes. A correct. What about B? Both spheres will have the same vertical velocity B at the same ground. Both velocity, vertical velocity, both spheres will have the same vertical velocity at the ground. එතන අර B අකුර අයින් කරන්න. මේක අදාළ නැහැ නේ. කියවද්දි තේරෙනවා ඒක. Vertical velocity is same. Today from here to here, vertically downward, it will obtain velocity of V. At here, vertical velocity of V, but it consists with horizontal velocity, same as the initial horizontally projected velocity. So, vertical velocity is same. එතන underline කරගන්න ඕනේ vertical velocities. මේ papers ඊළඟ physical date එක දවසේ ඔයගොල්ලන්ට හම්බ වෙනවා. එතකොට මේක ආයි කරද්දී ඒවා underline කරලා කරන්න, right? Here, from here to here, this velocity towards downward, vertical velocity is found by using u plus at. Vertically, downward velocity for both the cases is 0. Then final velocity decided by gt. T same, g same, then vertical velocity same. But final velocity of this one is greater as the resultant is added into this side. But VR is the resultant one. Right. Mark කරගන්නකො එහෙමනම්. A statement correct. B statement correct. C, the sphere B will have higher velocity than A at the ground. Yes, down. A, B, C, all statement correct. Fifth one is the correct answer. Okay. Can we check question number 11? Two masses, 8 kilogram and 4 kilogram, are connected by using light inextensible string passing over a smooth light pulley like this. Right here, no? Right. Of the weight, 80 Newton. Here weight is 40 Newton. Tension T as the light inextensible string. Both the tension to be same. This one is accelerating downward. With the same magnitude, this is accelerating upward. Then you are asked to find just the acceleration. Then simple calculation. This is, the string is passing over the pulley towards this side. No? Therefore, this side we have resultant towards this side, which means clockwise direction. We have resultant 80 minus 40. Applying F equal MA. 80 minus 40 equal 8 plus 4, 12. Acceleration A. 40 equal 12A. Here 10 by 3 equals A. Then ms minus 2. The answer is first one. Right. Can you copy this one? 11 answer is first one. Right. Number 12. An object of mass 1 kilogram is moving towards east. Towards east like this. Mass is moving with the velocity of 2. ms minus 1. A force of 2 Newton is applied towards north. This one is having 2 Newton force. Yes. The magnitude of displacement after 2 seconds later. As this velocity, this object should be travel into this side. Agreed. From here to here, we can apply S equal ut as towards horizontal direction, it has only that velocity. No, force is applied towards this side. No? So it could be S is velocity 2, time is also 2. Then 4 meters distance will be covered by the object towards that direction. And as this force towards northward, we can find the acceleration towards that direction. Towards northward, towards northward, we have applied force is 2, mass is 1 kilogram. Then you will have acceleration 2 ms minus 2. Is that clear? Towards that direction, we have acceleration. Then this should be transferred into this side, right? Into this direction. It will have an acceleration. Then towards this side, we can apply S equal ut plus half at square. Towards upward, right? Okay, then we have S to be found. Towards northward, no initial velocity. Initial velocity only directed towards eastward. Ut 0 plus half into acceleration. Its calculated one is 2. Time is 2 squared, right? 1, 2 cancel here. That direction we have 4 meters displacement. Towards this side we have also 4 meter distance. Then the object should be transferred like this. This is the real displacement of the object. පැහැදිලි? ඒ කියන්නේ මෙයා මේ පැත්තට තියෙන effort එක හින්දා එහාට යන ගමන් මෙහාටත් යනවා. නේ? ඒතර මෙයාගේ ඇත්තටම මේ path එක ඉන්න ඕනේ මෙහෙම මේ. The path of the motion of the object like this, but they need the displacement, not the distance. Displacement is the shortest distance between initial and final. මේක ඇඳගත්තා නම් වඩා හොඳයි නේ. Right. They need this one. And අපි ගමු here for Pythagoras. R squared equal P squared plus Q squared. 4 squared plus 4 squared. Then R becomes twice of 4 squared. Then S is 4 root of 2 meters. Can you put the final answer? Okay, then correct answer is second one. Right, number 13. While launching a rocket, rocket යවන්නේ කොහාටද කියලා දෙන්න ඕනේ නෑනේ. ඒක දන්නවනේ. Launching a rocket like this. Right. It is launching upward. Okay, then the force of 10 to the power 6 Newton towards upward, applied force is 10 to the power 6 Newton, having the mass of 10 to the power 4. පුතේ ඔයාලා ගොඩාක් අයට අමතක වෙනවා. මේකේ weight එක ලකුණු කරන්න. It becomes 10 to the power 4, 10 Newton downward. Then you are asked to find velocity attained at the end of 10 seconds. Then we can say F equal ma towards upward. Upward we have 10 to the power 6. Backward we have 10 to the power 5. Mass is 10 to the power 4. Acceleration A. 4 cancels, right? Here 2, here 1 available. 100 minus 10 equal A. A becomes 90 ms minus 2. But they need the velocity. V equal U plus 80. V becomes U0 plus acceleration 90. T squared is 10. Sorry, T is 10. V is not 1000 ms minus 1 could be 900 ms minus හදිසියට ඔගොල්ලෝ මේක අමතක කරලා උත්තරේ 1000යි කියලා ගන්න එක වැරදි ඈ right වැරදිච්ච අය ස්ටාර් මාක් දාලා ඒවා මාක් කරගන්න කොතන හරි වැරද්දක් වුණොත් වැරද්ද කපන්න එපා පුතා හොඳට පේන එක highlight කරගන්න ඒ කියන්නේ ඔය first time ඔයා කරන වැරද්ද and definitely you will done again පුතා right you will be done again definitely අයගේ තර්කයක් නැහැ. ඔය පළවෙනි පාර ගහන ගොම් පාට් එක තියෙන්නේ. ඔය ගොම් පාට් එක රිපීට් කරනවාමයි. ඒක තමයි ලෝක ස්වභාව ධර්මය. ඔව් පළවෙනි පාර වරද්දද්දී ඒක හරියට ක්ලීන් මයින්ඩ් ගත්තේ නැත්නම් සෙකන්ඩරි තව සතියක් දෙකක් ගිහලා මේක ගත්තොත් ආයෙත් අර වරද්දපු විදිහටමයි හදන්නේ. ඒ හැටි නේචර් එක. එන සිහි කල්පනාව තිබ්බොත් තමයි ළමයා තීරුම් ගන්නෙ. මෙතන වැරදුනා ඒ නිසා මේක රිකවර් වෙන්න ඕනි මේ විදිහට කියලා. පැහැදිලි? ගන්න බලන්න. next one. number 14. Right, two masses 10 kilogram and 20 kilogram like this connected by using this kind of helix spring. Okay, here 20 kilogram, here 10 kilogram. Massless spring. This is massless spring, right, Buddha? Massless spring, then we can say applied force is 200 Newton. And here we have backward tension, let it T, at here tension offered like this. And then you are given 10 kilogram mass consists with 12 ms minus 2, this one. 12 ms minus 2. Then we can apply F equal ma for 10 kilogram. For 10 kilogram, we have applied force, only this one is consisting, T, equal mass 10 kilogram, acceleration 12. T becomes 120 Newton, right? And for this case, this is also 120 Newton. Then applying F equal ma for 10 kilogram. Then you can say F towards that direction 200. Backward we have 120 equal 20 into acceleration A. As the spring is not the fixed one today. It will stretch. It will stretch definitely. Then those two objects will have two different acceleration. පස්සේ ඕක ඇදිලා දෙන්නම එකම acceleration එකකට එනවා. At this instance පුතේ. At that instance, right? Okay. Then we have 80 equals 20A. Then A becomes, let it 4 ms minus 2. Then correct answer is first one. Can you note down way of calculation? Right, Buddha? Clear. Can we check next one? Number 15. Fifteenth one. Two masses A and B, 10 kilogram and 5 kilogram. It's a table like this. One object is placing like this, and another we have here another suspended mass of B. Respectively, then 10 is this one. This is 10 kilogram. This is 5 kilogram. Okay, right. What's next? Are connected with the string passing over a frictionless pulley fixed at the corner of the table as shown. The coefficient of static friction between A and the table is 0.2. Coefficient of friction is mentioned. Then can we note the friction right here? This is friction. Okay. Next, the minimum mass DC that should be placed on A to prevent it move. Then this is not moving. Velocity is 0. This is at rest. Then weight 50 Newton. Here we have tension. But as there is no motion of this one, this could be equal to this one. Then T tension should be 50 Newton. Okay? Yes. Then this is tension. Frictionless pulley. This is also 50 Newton. Here, the force towards the right side is also 50 Newton. Then this object is experience the applied force 50 Newton. It prevents the motion. Then friction should be equal to 50 Newton. As the masses remain at rest, right side force should be equal to left side force. Mark karaganda forces stick. To prevent it move, downward force equal to this tension. කියලා දෙද්දි හොඳට අහගෙන ඉන්න ඕනේ. වෙන කතන්දර ඔලුවට ගන්න එපා. වෙන අවධානයට යන්නත් එපා. අල්ලගෙන ඉන්න, right? As this object is at rest, weight equal to tension. Tension delivered, distributed throughout the entire length with the same value here, 50 Newton done. Then as this complex is kept at rest, this 50 could be equal to friction. Then frictional force is 50 Newton done, right? Then you can say F equal mu r for these two, right? දෙන්නටම එකට දාන්න වෙන්නේ. මෙයා උඩනේ මෙයා ඉන්නේ. Then let the normal reaction is R. So the whole normal reaction is R. Then you can say friction is 50 equals mu 0.2 R. Then R becomes 50 over 0.2, no? 50 over 225 as decimal place, it becomes 250 Newton. Then, so they already, we have 100 Newton weight. And we have another mass, let it mg here. Then you can say 250 equals R plus mg. Sorry, 100 plus mg. No? Yes. G0 cancel. M becomes 15 kilogram. We need additional 15 kilogram to prevent it move. Can you copy the answer? Then answer is fourth one, right? Okay. Correct answer is fourth one. Right, done. Number 16. A uniform rope of length L, uniform rope of L is pulled by a constant force as shown, like this. Here we have a rope. A force is applied, F. The tension in the rope at a distance of x from the end where the force is applied. මෙතන ඉඳලා x දුරකදී ඔයගෙන් අහනවා tension එක. ඉතින් අපි පොඩි වැඩක් කරමු මෙහෙම. මොකක්ද? This string is broken into two pieces like this. This string is broken into two pieces and they are connected by using light inextensible string. Let this length x, right? This length is x. This length is L minus x. Clear? Okay. Then applied force is F. Applied force is F. Then let the tension at here T. Today you are asked to find this one. That is the tension at the point of x. And here massless string. There is no effect of presence of this one. Additionally, this is used, right? අර මොකක් හරි rope එකක් හරි chain එකක් හරි දීලා අපිට යම් තැනක ඇහුවොත් tension එක අපිට මේ විදිහට කෑලි දෙකකට මේක කඩන්න පුළුවන්. Can you copy this one? Now you are asked to find this tension, right? We can find how. Right, let's see the next one. When we consider density equal mass over volume of this wire, right? Mass of the wire to be considered now. Density equal mass over volume. Let the area cross section of this wire A, this is also A, this one is also having A. Then the mass of the string can be written by using density into volume. Volume is area into length L, right? If you consider this mass, it becomes density into area into total length, right? Mass of this one, let it M1, it becomes density D, area A, and length is X. Mass of this one, M2, density D, area A, length L minus X. That could be the mass. Then you are asked to find tension T. The tension you should find common acceleration. මෙයාට force එකක් දීපු ගමන් මෙයාගේ acceleration ඔයා හොයලා ඉන්න ඕනේ. Right. We are going to find that acceleration. ලියන්න පුතේ යටි. Finding the acceleration. Okay. Applying F equal ma. Applied force is F. Mass is density into volume into length L multiplied by acceleration A. Then A could be F divided by dVL, right? Let it first one. Now you are asked to find this tension, right? We are going to place F equal ma, F equal ma for this one, for M2. Can we? F is this tension, T, equal, mass is M2, it's dAl minus X. Acceleration, we have found that one, F divided by dVL. Then, sorry, dAl, right? dAl. Then dA cancels. Then T becomes F into L minus X over L. So answer, we can replace the answer now. Tension equal F, you can say L over L minus X over L. Done. So T becomes 1F times of 1 minus X over L could be the final answer. Right, can you complete this now? Okay, right. Number 17. Number 17. We have an inclined plane like this. It consists with three masses, right? Here we have first one. Here we have another mass. Spring balance available with the hook. And here we have another mass, right? Here 2 kilogram. The spring balance consists with the weight 2 kilogram. It's 20 Newton. And here weight is 60 Newton. But you all know towards this side we have, this is also 30. No? Here we have 60. Sine 30. It's 30 Newton. But towards this side we have 30. Toward downward we have 40 Newton total weight. No? Then we all know large force is available towards this side than along the inclined plane, right? Then this is going upward. This is coming downward. Right? Can we copy now? Now apply F equal ma towards the moving direction at once. This is MCQ question or not essay question? This is not an essay question, just simple MCQ question. So apply F equivalent. You are asked to find the reading of the scale, no? What is the reading of the spring balance? They need this tension. You are asked to find this tension. This tension is the reading. Mark. This is the reading. The reading is the tension at the hook. Hook එක උඩ පැත්තේ තිබ්බනම් උඩ tension එක හොයන්න. හරි. Now, first thing, we are going to find common acceleration. Applying F equal ma towards clockwise direction. Clockwise we have 40. But the anti-clockwise we have 30. It could be minus. Towards the rotating direction could be the positive one. Minus 1 is the backward one. Equal total mass 2 plus 2, 4 plus 6, 10. A. It's here 10 equals 10A. Acceleration becomes 1 ms minus 2. Done. Now we are going to find this tension. As it is going down, we can say F equal ma towards downward. Here, only for this one, right? Only for this 2 kilogram. 20 minus T equal 2 into 1. T becomes 18 Newton. The reading is 18 Newton or 1.8 kilogram. Both are correct. But the given answer is fourth one, right? Okay. Can you complete now? A block of mass 2 kilogram is kept on the floor. The coefficient of static friction is 0.4. If the force of 2.5 newtons is applied on the block as shown in the figure, like this. Here we have a block. The applied force is just 2.5 Newton. Right. Then frictional force should be created into this side. This is the friction. A friction එක කීයද කියලා අපි හොයන්න කලින් we are going to find the maximum friction. Finding maximum friction. මෙන්න මේක තමයි ඔයාලට equation එකෙන් එන්නේ. When we apply this one, F equal mu r, F frictional force, you should know this is maximum. Mu value, it was mentioned just 0.4. Normal reaction is 20. Then it should be 8 Newton, no? Maximum friction is 8 Newton, but maximum friction is not operated at here. Reason? To operate maximum maximum friction, we should apply the value equal to that maximum friction or greater than that one, right? The maximum friction එක ගන්න මෙතෙන්ට 2.5 දීලා maximum friction ගන්න බෑ. එහෙනම් in this case frictional force is just 2.5 Newton. First answer is the correct one. එහෙනම් note එකක් දාන්න එතන. Okay. Maximum friction is not created. Maximum friction is not created as the applied force is just 2.5 Newton. 2.5 Newton. Then the frictional force is just 2.5 Newton. Okay. Number 19. Kinetic coefficient of friction and static coefficient friction respectively mentioned 0.4 and 0.5. Yes. On the mass of, let's see, how about 19? 19 ටිකක් වෙනස් question එකක් පුතේ බලන්න. Here we have a mass, but a static coefficient is mentioned. Then if you apply this one, the maximum static friction, Fr maximum value is found. This is 0.5. Here weight is 20. No? The normal reaction is 20. Then you will have 10 Newton of force as the maximum static friction, and maximum kinetic friction is written. It's mu r, mu k. It's 0.4 into normal reaction is just 20. It could be 8 Newton. It's here kinetic friction. An object එක move වෙද්දී තියෙන friction එක මෙච්චරයි. යාන්තම් හොල්ලන්න තියෙන ඕනි friction එක මෙච්චරයි. එයාලා කියනවා මොකක්ද? If a force of 10 Newton is applied to start the motion, and underline කරන්න. 10 Newton is applied to start. ඒ කියන්නේ Newton 10ට මෙයා start කරලා තියෙනවා. පුතාලා දන්නවා as soon as starts the motion. As soon as starts the motion. Clear? Inertia will be vanished. Then the frictional force is dropped down to 8 Newton. Applied force is 10 Newton. Then it is dropped. The frictional force is as soon as starts the motion. If you have supplied just this one, frictional force is dropped to as it is start to move. As it is starting to move. මේගොල්ලෝ කියලා තියෙනවා මේ 10 Newton is applied to starts the motion. Now, 10 Newton is just enough to drag, just dragging the object. Verge of dragging, almost dragging available on here. එනම් පුතේ Newton 10ට මේ ගානේ හැටියට object එක drag වෙලා තියෙනවා. And as soon as it is dragging along the surface, then friction becomes 8 Newton. Then object does have the acceleration such as 10 minus 8 equal mass is 2, acceleration a. It's 2 equal to a becomes just 1 ms minus 2. That is a smart question. ඒගොල්ලෝ අර වචනයක් දීලා තියෙනවා පුතේ මම ඒකෙන් හැදුවේ මොකද්ද? 10 Newton is applied to start the motion. ගමන් ආරම්භ කිරීම සඳහා ඒගොල්ලෝ දීලා තියෙනවා නිව්ටන් කීයද 10ක්. ඒක අන්ඩර්ලයින් කරගන්න. පේපර් එක අතට හම්බුණාට පස්සේ ඒ ටික කරන්න දැනට නෝට් ඩවුන් කරගන්න මේ පොයින්ට්ස් ටික. Okay. Then The acceleration is not zero, right? Yes. ඔන්න බැරි වෙලාවත් මෙයාලා kinetic කතාව දීලා නැත්නම් මම උත්තරයට ගන්න බිඳුවයි කියලා. If it is not specially mentioned, the kinetic static value, sorry, kinetic coefficient of friction is, if it is not mentioned, our answer is just 0. But here, mu k is given. Mu k means kinetic coefficient of friction is mentioned. Then, if you have applied just 10, it is trying to start the motion, right? As soon as starts the motion, definitely kinetic friction available. Kinetic friction is relatively low value. Then the 10 Newton is enough to accelerate the object. Done. That's enough, right? Number 20. Okay, can we read now? Static frictional force. Number 20, it's better to remember this graph here. Frictional force against applied force, like this. Static friction is this one, no? This is static. Static friction is always depend on the normal reaction on the object. Wrong to that. A statement is completely wrong. Why? Not always, right? At here, kinetic friction, sorry, static friction depend on normal reaction, correct. At here, maximum static friction depending on the normal reaction, agreed, but not always. මෙතන ඉඳලා මෙතෙන්ට friction එක depend වෙන එක fact එකයි තියෙන්නේ මොකක්ද? Applied force. Static friction only depend in the applied force. එක ලියා ගන්න. Static friction only depending the applied force. B, kinetic friction depends on nature of the surfaces. Yes, perfect. If the nature of the surface is rough, kinetic friction, limiting friction, both are high. If the surface is smooth, kinetic friction definitely low. Z, kinetic friction always depend on the normal reaction on the object. The kinetic friction has a definite value. Then F equal mu kr available. Mu k depending on the nature of the surface. Right here, A statement is wrong, B correct, Z correct. Then, wow, incorrect answer, Sahan. Economy uttare, paha uttare. Fifth answer is the correct one. Right, that is the complete discussion of fourth paper sets, right? Okay.